see the difference. And because it holds locks for longer, this level definitely increases the potential for blocking compared to read committed, significantly. Action proposed for the cloud database professional. Use repeatable read when you absolutely must ensure that data you've already read stays unchanged for your whole transaction. But be super aware of the increased locking and the phantom read potential, which can be tricky to debug. Test thoroughly for concurrency issues like blocking, especially under high load. You're trading some concurrency for stronger read consistency. It's a conscious choice. 2.4 is serializable. Okay, what it is, this is the top dog. The most restrictive ANSI isolation level. And it really lives up to its name. Serializable tries to make concurrent transactions behave as if they ran one after another in perfect sequence, serially. To do this, it holds locks until the transaction completes. It stops others not just from updating or deleting rows you've read, but also from inserting new rows that would affect your transaction's results. It provides the highest level of consistency in the traditional locking model. Phenomena allowed, none. Zip, nada. When you run it serializable, you're guaranteed. No dirty reads, no non-repeatable reads, and no phantom reads. It's like your transaction gets a completely isolated, static snapshot of the data for its entire life. How does it prevent phantoms? It uses not just row or page locks, but also range locks. Think of it like reserving a block of seats in a theater. You don't just lock the seats you're using, but also the empty ones next to them in your range. This stops anyone else from inserting a new row into that range you've queried. The high cost. Okay, here's the massive trade-off. This level severely impacts concurrency, often prohibitively so. Because it holds locks for the entire transaction and uses those restrictive range locks, it can easily cause widespread blocking and deadlocks. If a serializable transaction reads even a moderately wide range of data, it could lock out a huge chunk of your database for everyone else, effectively grinding your system to a halt. It gives you perfect data integrity, sure, but often at the cost of killing performance. Recommendation. The strong advice from our source, and really any experienced DBA, is use this only when absolutely necessary, and only after incredibly careful design and extensive realistic testing. You must evaluate if a lower level, or perhaps the optimistic snapshot isolation, could work instead. Often, serializable gets chosen by accident or without fully grasping its massive impact, leading to hidden performance nightmares. Action proposed for the cloud database professional. Understand the immense power, but also the severe danger of serializable. If a business rule truly demands absolute transactional isolation where even phantoms are unacceptable, think critical auditing, financial ledgers, then okay, maybe. But always look at alternatives first, like snapshot isolation, or maybe redesigning your application of logic to minimize the scope and duration of the serializable transaction. This is definitely not a default setting, and it shouldn't be used casually, ever. 2.5 snapshot and read committed snapshot, RCSI. Okay, what they are. These are SQL Server's optimistic row versioning levels, a really modern and often much better alternative to traditional locking, especially for reads in busy OLTP systems. Instead of using shared locks when reading, these levels read a consistent snapshot of the data. This snapshot comes from a version store that SQL Server maintains, mostly in TempDB. Let's break down the two key flavors here because they're slightly different. RCSI, read committed snapshot. Now, this isn't technically a new isolation level you set in your code for every query. It's actually a database level option you turn on. And what it does is change the behavior of the default read committed level. When RCSI is enabled on your database, normal read committed statements just stop taking shared locks for reads. Instead, readers don't block writers. And crucially, writers don't block readers. Magic. Readers see the latest committed version of the data that existed when their individual statement began. It's a statement level snapshot. This one is an explicit isolation level you set. Set transaction isolation level snapshot. It provides a transaction level consistent snapshot, meaning it sees the data exactly as it was when the transaction itself started. So a long-running Snapshot transaction will always see the exact same data, frozen in time from when it began, even if other transactions commit changes later. This makes it perfect for complex reports or batch jobs that need a perfectly consistent view over a long time. The benefit. The huge win, especially with RCSI, is a dramatic reduction in blocking and deadlocking for reads. Because readers aren't taking shared locks that writers pump into, and they aren't waiting for writers to finish, overall concurrency just shoots up. This is massive for busy OLTP systems where read contention is common. It basically decouples readers from writers. They can both get on with their work without tripping over each other. The trade-off, okay, it sounds amazing, but there are trade-offs. Always are, right? The main one is increased workload on TempDB. SQL Server has to store the old versions of rows somewhere when data changes, so snapshot readers can see them. That somewhere is TempDB. If your TempDB isn't sized right, configured well, or on fast enough storage, it can become the new bottleneck. Also, with the full snapshot isolation, you can get update conflicts. If your snapshot transaction tries to update data, but someone else already changed and committed that same data after your transaction started, your update will fail, usually with an error message, because your view of the data was stale compared to the latest reality. This means your application code needs careful error handling and maybe some retry logic. RCSI usually avoids this specific conflict because it's statement level, not transaction level. Action proposed for the cloud database professional. Seriously consider enabling read-committed snapshot RCSI on your databases, especially OLTP ones. For most modern workloads, the concurrency gains and blocking reduction far outweigh the extra tempted reload. It's often a foundational database-wide change that gives you immediate, significant improvements in responsiveness. Use the full snapshot isolation level more selectively. For those specific long-running reports or analytical tasks that truly need that transaction-wide consistent view. But make sure your application is built to handle those potential update conflicts gracefully. RCSI is often the better starting point.
Okay, this is where it gets really interesting and honestly quite surprising sometimes. You might be there meticulously setting your isolation levels in your T-SQL code thinking, yep, I'm in control. Or maybe you're just relying on the database default, assuming it's fine. But the kicker is, external factors, often coming from the application layer, can secretly mess with this, change your effective isolation level without you even realizing it. And this hidden complexity, it can cause completely unexpected locking, blocking, or worse, those subtle data inconsistencies that are just a nightmare to trace. What are some of these sneaky culprits we need to watch out for?
Oh, this is such a critical area. It really bridges that gap between database theory and what actually happens in the real world in your applications. This is where a lot of those really baffling database mysteries actually live. 3.1, the connection pooling trap. Explanation. Okay, so modern apps, right? Especially .NET with A2.NET, Java with JDBC, they all use connection pooling heavily. It's a massive performance win. Instead of opening and closing a brand new database connection every single time, which is really expensive, connections get put back into a pool when you close them in your code, then they get reused by the next request that needs one, so you have a ton of overhead. But here's the catch. When a connection goes back to the pool, it usually keeps its last used settings, including its isolation level. The problem. The trap happens when the next process grabs that exact same connection from the pool. Let's say some previous process, maybe a bit careless, set the isolation level really high, say serializable for some specific task. And crucially, it didn't send it back to the default before returning the connection to the pool. The next process that grabs that connection, it silently inherits serializable. So now, a piece of code that was only meant to do a simple read, maybe expecting read committed, is suddenly holding super aggressive, long-running locks. This causes blocking all over the place. Deadlocks, maybe? And the really insidious part. The code for this victim process looks totally innocent and never asked for serializable, but it's suffering the consequences anyway. It's like picking up a rental car someone left stuck in first gear. You just wanted to cruise, but now you're stuck. Demonstration insight from source. Our source material has this brilliant C# demo that shows this perfectly. It simulates a careless process explicitly setting serializable on its scall command, doing its work, then closing the connection, returning it to the pool, then a victim process runs. This victim never sets an isolation level, it just opens a connection. But the demo shows it gets the exact same connection from the pool. How? The etcd ID, the server process ID, is identical for both. That's the smoking gun. And when this victim process tries a simple select that should be fast under read committed, boom, it gets blocked by some external transaction that wouldn't normally cause a conflict. It proves, without a doubt, that the serializable level was inherited from the pool, causing totally unexpected blocking. Action proposed for the cloud database professional. The takeaway. Always be explicit and defensive in your application code, especially when using connection pooling, which is almost always. Don't just assume the default isolation level is active. At the start of any critical transaction, or even just for important queries, explicitly set the isolation level you need. Set transaction isolation level read committed, or whatever is appropriate. This tiny bit of defensive coding stops your code from becoming a victim of a polluted connection from the pool. It buys you so much stability. 3.2 application frameworks and ORMs, object relational mappers, explanation. Right, so lots of modern apps use higher level stuff, right? Entity framework in .NET, maybe Dapper, Hibernate in the Drago world. These frameworks give us nice abstractions for talking to the database, including managing transactions. Makes life easier for developers often. A really common one in .NET, for example, is the transaction scope object. It's super convenient for wrapping code in a transaction, even across multiple resources sometimes. The issue. Here's the hidden danger. the defaults these frameworks often choose for you. Developers often use transaction scope because it's easy without ever checking what isolation level it uses by default. Guess what? In Dot, the default transaction scope uses Serializable, the most restrictive one. So a developer, completely unaware, can easily end up running queries at the super restrictive level, killing concurrency, without ever typing set transaction isolation level serializable themselves. I've personally seen major production outages caused by exactly this. High traffic operations wrapped in a default transaction scope, grinding the whole system to a halt under load. It's a silent concurrency killer.
Don't miss out. Smash that like button, subscribe, and explore our other videos in the playlists.